All right, let's talk about 7.1, number 19. And so Jordan, I think, posted this question. Said I substituted 3 to the square root of x for u. But then when solving for du, I got a little confused on how to handle everything else. So, by the way, you're going to hear my kids in the background being crazy as usual. But anyway, I would say, so that's not the choice that I would make for u. I wouldn't let u be 3 to the square root of x. But we can try it that way and see where it leads us. So if we say let u be 3 to the root x, then du would have to be, oh goodness, this is an exponential, so you would do, but it's not base e though, it's base 3, so I think you'd have to say it's ln3 times 3 to the root x times the derivative of root x, right? X is x, or root x is x to the 1/2 power, so this would be 1/2 x to the negative 1/2, or in other words, 1 over 2 root x. Actually, this could work, I think, now that I'm looking at it. Sorry, dx, I'm missing. Because we need a square root of x in the denominator, which we've got. Oh, but we would need a 3 to the power of the square root of x in the numerator, which we don't have, right? We've got that thing. We might be able to fix it up with some tricky algebra, because it does seem kind of like we've got all the pieces in a way, but I don't know if it's really going to work out for us. So let me suggest a different u. So instead of letting u be 3 to the x, just let u be the square root of x. And the reason for that is I know that the derivative of this is going to be 1 over 2 root x, and there's a 1 over root x sitting right there. So I'll be able to replace that with just the du part, and I'll be able to replace this with just u. So if I let u be square root of x, then du is going to be 1 over 2 root x dx. Or in other words, I could call that, I guess, dx over 2 root x. So I'm going to give myself a 2 there, which is really a 1/2, right? So I'm going to offset it with a 2 out there. And then this dx over 2 root x is going to be replaced with du. Okay, so what I'm going to get is 2 times the integral of du over 3 to the u. Well, that's the same thing as 2 times the integral of 3 to the negative u du. So that's another exponential type thing. So goodness, I always have to like think through these, but yeah, this would be 2 times 3 to the negative u over ln of 3, and then for the chain rule, you've got to make that thing negative. So I think it would be 2 times negative of that stuff. I think that's right. Because then you'd get if you were to take the derivative, you get 3 to the negative u times the derivative of negative u, which would be negative 1, and that takes care of that negative sign, and then times ln of 3, and that would get rid of that ln of 3. So I think that does the trick. I mean, you have to back substitute now, of course, to get it back in terms of x, but this would be negative 2 times, well, and actually, well, let's just write it this way. Not u, sorry, to the negative root x over ln 3 plus c. Or better yet, you could say it's negative 2 over 3 to the positive root x times the ln of 3 plus c. I don't know, something like that. I'm not exactly sure how the book will have the answer, but that's that one.